Now, if we desire, we can also use reference angles to evaluate trig functions. The only thing is we have to be careful because we do know that trig functions can be positive or negative, depending on where that terminal side lies, depending on which quadrant it is in, right? So even if we use reference angles to help us there, we do have to check the sign at the end. So let's say you do want to use a reference angle to help you figure out a trig function. You can find the reference angle and you can find the trig function value for that reference angle, but then you need to check the sign afterwards. So remember that, wherever the original angle lies, whatever quadrant, that's the sign you want to use. So in the first quadrant, all of them are positive. In the second quadrant, only sine and cosecant are positive. In the third quadrant, tangent and cotangent are positive. And in the fourth quadrant, cosine and secant are positive. So let me show you what I mean here. Now, some of these steps you may find a little redundant because, we do have tables that, have values like sine of 135. That's a pretty common value. So there's something that you may already know and say, well, I don't need a reference angle there to find that, and that's fine. But maybe you don't already know that, but you know your acute angles really well. So maybe you do know your sine, cosine, tangent of like 30 degrees, 0, 45, 60, 90, or something like that. So maybe you know the first quadrant really well, but not the other quadrants. That's when this is helpful for you. So the first thing I'm gonna do is I'm gonna draw the picture. So I'm in degrees here. So 90 degrees, next set is 180, that's too far. So it's gonna be somewhere in the second quadrant. And again, let's pretend like I don't know what sine of 135 degrees is, but maybe I know my first quadrant really well. So I'm going to find the reference angle, which is right here. And because I'm in quadrant 2, I can use the idea that the whole thing should be 180. So if I take 180 and I subtract out 135, I end up with 45. So my reference angle is 45 degrees. Now, hopefully you remember that the sine of 45 degrees is just square root of 2 over 2. We've seen this one a few times in the videos already. So again, hopefully you recognize that. Now, the only thing you have to do is, please, if you're using reference angles, don't forget to check your sign. So remember, our original angle was actually in the second quadrant. So if I go to my second quadrant, I see that sine is positive, so it actually will stay positive. But you need to check that. So where is your actual angle? Well, my actual angle was in the second quadrant. In the second quadrant, sine is positive, so it will stay positive. Okay, let's do another one. We'll do cosine of 4 pi over 3. And again, for these, I won't lie, I'm actually not a super visual person. I tend to like steps and things like that better, but for this stuff, I really need to see it. I need to know where it is in those quadrants. So I do draw the picture and I highly recommend it. Now we're in radians here, so we gotta be a little careful. I'm starting here. Now my first set would be the pi over 2. This is definitely bigger than pi over 2, right? This is over 1. My next set here would be at pi. Again, this is over 1, so we're bigger than pi. But we're not that much bigger, we're only a little bit bigger. So we're just going to end up going into the third quadrant here, maybe right here. So this is going to be my reference angle right here. And again, oftentimes in the second and third quadrants, I can use that idea of 180 degrees or pi radians to get back. So to find this, what I can do is subtract out the first 180 degrees, and then whatever's left over will give me that reference angle. So here I'm in radians, so I'm going to do pi minus 4 pi, or sorry, the other way around, 4 pi over 3 minus pi. In this case, because again, I want the positive answer, right? Make sure I have common denominators and I have pi over 3. So my reference angle there is pi over 3. Now I'm looking for cosine. So I'm looking at cosine of 4 pi over 3. And again, we've seen this one before. So if you don't know these by heart, it's okay, but I would start keeping a table or a list with you as you're doing your work. for those really common angles and sine, cosine, tangent values, because you don't want to have to always be finding them and drawing pictures over and over again. So we have done this one before. Oh, sorry. So I'm going to do the reference angle first. Let me do the reference angle first here. So pi over 3 is my reference angle, and we've done this one before, which is 1/2. Actually, I should clarify over here too. So the reference angle was 45 degrees, but actually, I guess I should rewrite this because my question was about 135 degrees. So I'll rewrite that. So here, cosine of pi over 3 is 1/2. Now, be careful, our original angle was in the third quadrant. And if I go up here, in my third quadrant, only tangent and cotangent are positive, which means that my answer here should actually be negative. So cosine of 4 pi over 3 would actually be negative 1/2 instead. Okay, let's do another couple. Same thing. Draw my angle first. Now it's negative, here's something in the opposite direction. Remember, my first spot would be 90 degrees or negative 90 degrees. So I guess negative pi over 2 here. This is smaller, so I'm not getting out of the first, I guess the fourth quadrant. So I'm just gonna, again, I'm just drawing approximately where the angle is. And that's negative pi over 3. Now for this one, it's kind of really nice. The reference angle is actually the same thing, but the positive version. Right, because we're just connecting back to that x-axis. It's the same distance, that same angle is being shown, but the positive side. So what I'm going to do here is I'm going to find cotangent of positive pi over 3. And again, this is one that we have seen before. So cotangent of pi over 3 is root 3 over 3. And then I do need to check my sine. So if I go back up here to my little chart, again, I was in the fourth quadrant. So in the fourth quadrant, only cosine and secant are positive. So that must be my answer is negative instead. So cotangent of negative pi over 3 is negative root 3 over 3. And let's do another one. Again, we're just doing a lot of practice with these just to get used to that process. Here, I'm going to draw the picture. I am going to note that my angle first is really quite large. It's in radians and it's going around quite a few times here. So I'm definitely going to subtract out 2 pi's until I can get down to something more normal. So let me take that 14 pi over 3. I'm going to subtract out a 2 pi first, so 1 full rotation. And just watch your common denominators. 2 pi would be 6 pi over 3. That's a minus sign. So I have 8 pi over 3. It's still pretty big, so I'm going to do it again. 8 pi over 3 minus 6 pi over 3 gets me down to 2 pi over 3. So that angle is, again, a little bit more reasonable to work with here, and it gives me the same answer. So this is not a reference angle. This is coterminal angles. Subtracting or adding out 2 pi or 360 degrees does not change the value of tangent or any of the trigonometric functions. So I don't have to worry about positive or negative. It's actually the same exact terminal side. I'm just not going around the circle 2 extra times. That's what this is doing here. By subtracting those out, we don't have to go around the circle the extra time. So now I am at, let's see, where are we at? We're at 2 pi. All right, so I start here. Now this is pi over 2. 2/3 is definitely bigger than 1/2, so I know I'm going past that. But this is pi and 2/3 is less than 1. So I'm not going past pi. So maybe it's, I don't know, somewhere in here. So this one is going to be my reference angle. And again, I'm noticing that the total here would be 180 degrees or pi radians. So I'm going to use that idea. So my reference angle is going to be pi minus 2 pi over 3, which is 3 pi over 3 minus 2 pi over 3, which is just pi over 3. So now I look at, okay, well, what is tangent of pi over 3? All right, and the value there is just the cubed root of 3. Again, this one we've seen before. So we have that, but we do want to be careful. I need to know the sign. So I'm in the second quadrant. And if I go here, I see that only sine and cosecant are positive. So my answer must actually be negative. So tangent of 14 pi over 3 is actually negative root 3. Okay, so just a reminder there that, again, if your angle is really large, you don't have to circle around the circle multiple times. Adding or subtracting that 2 pi or 360 degrees is not going to change where that angle, that terminal side ends. So that has nothing to do with the sign. It's just making the angle easier to visualize because you don't have to keep circling around the circle. And then the reference angle is the one where you do have to be careful of the sign if you're trying to find trigonometric functions. Right? If you're not doing that, if you're just finding the reference angle is always positive. But if you're trying to find sine of that angle or cosine or whatever, then again, you want to be careful of that final answer there when computing this. And one last thing I recommend, I know I've said this, but have a running list. So there's lots of pictures that you have that you can print out offline, that you can make a list on your own, make a little note card, but put on those common angles that we've seen, put on the common changes between radians and degrees as well. So if there's ones, again, that you're always seeing over and over again, just make a little note card for yourself. Okay, these are common angles and radians that, you know, the conversion, so you don't have to constantly do it. Or if you're always finding sine of 45 degrees or sine of 30 degrees, again, just make a little note card for yourself. And then that way you're not constantly going back and saying, okay, what was that answer? Or yeah, how do I find that again? You can use those. So there's lots of charts that you can make on your own. You can print them off online. We've done some of them in videos too. So keep yourself organized, keep those little reference sheets close to you, and that will really help speed up the work as well.